Let's find the equation for this graph. First, we must find the zeros of the function. So let's click on this graph and the zeros will be highlighted. So here's one x-intercept. And we see here that we have -6, 0. And this is the reason why we called -6 a zero of the function, because the y value is 0. Here's another x-intercept. And so we say 1 is a zero of the function. And here's the last one, 6, 0. So we say 6 is a zero of the function. So now that we see all of the x-intercepts of the graph, we can write the equation of the graph in factored form. So here I'm going to write y equals parentheses. For the first 0, the factor for that is x plus 6. And then for the next 0, 1, 0, I will write the factor x minus 1. And the last 0, which is 6, 0, we will write x minus 6. All right, now first let's change the color of the graph to a different color. Let's make it blue so that we know which one is new and which one is original. All right, so we see here that the graph goes through those x-intercepts, but it's different from the original graph. It doesn't fit yet. So what we need to do next is to find out how the graph behaves in each of the x-intercepts. So let me hide this first. Okay, this is the original graph, and we notice that at -6, the graph is bouncing off of the x-axis. It is not crossing. It is bouncing up. So it's going up, touches the x-intercept, and then comes back down. So if it bounces, we know that the multiplicity of that 0 should be even. And so we're going to put here 2. All right. Now at x equals 1, the factor for that is x minus 1. The graph is crossing the x-axis. So see, it's here, right here, it's in the negative territory. Now it's going to the positive territory. So it crossed the x-axis at 1. Again, the graph crossed the x-axis at x equals 1. And it's crossing it slowly. It's crossing it in a curvy path. So we know that if the graph is crossing the x-axis, the multiplicity is odd. And if it's crossing the x-axis slowly, like in a curvy path like this, the multiplicity should at least be 3. So here we'll put 3. And then at 6, we notice that the graph is crossing the x-axis in a straight path. So it's not slowing down. It is going from the positive territory to negative territory. So here the multiplicity is odd, and that's going to be 1 because it's crossing quickly, crossing the x-axis quicker. So let's put here to the first. All right, now let's take a look at the graph and see if they fit. They don't fit yet, but we see that the behavior of the graph at those x-intercepts are similar. Like at -6, the red graph bounces off the x-axis and the blue also bounces off the x-axis. We also notice that the two graphs are reflections of each other over the x-axis. So if that is the case, we just need to put here a -1 in the leading coefficient and see what happens. There you go. We have a perfect fit. So now let's go to another equation or another graph. Let's find the equation for this. So I'm going to find the x-intercepts. Okay. First one is -3, 2 is a zero of the function, and 6 is a zero of the function. So let's write the equation in factored form. So I'm going to put here y equals parentheses. Okay, let me grab this here. Okay, so I'll put here x plus 3 times x minus 2 times x minus 6. All right, and then let me change again. All right, and then hide first. So at -3, the graph is crossing the x-axis and in a curvy path. Therefore, its multiplicity is at least 3. So I'm going to put here to the third. Then at 2, the graph is bouncing off. See, it's bouncing off the x-axis. So the multiplicity is even and it's at least 2. So we'll try 2 here. Then at 6, the graph is also bouncing off the x-axis. So let's try here 2. Okay, so now let's take a look at our graph. The graphs have the same x-intercepts and the same end behavior. So they both go down on the left and they both go up on the right. The only problem is they don't fit in some places. We notice that the original graph, the red graph, is taller than the blue graph. That means that I need to stretch the blue in order to fit in the red. So, in order to stretch, my leading coefficient should be increased. So let's try 2. Not yet, but it's getting closer to the red graph. The blue is getting closer to the red graph when we increase the leading coefficient. So let's try 3. Okay, closer. Let's try 4. There it is. We now have a perfect fit.